Hi guys, back again to talk about sodium hydrogen carbonate more.
All right, so let me just get settled here where I'm at. There we are. All right, so remember our chemical reaction NaHCO3 plus HCl. Oh, sorry. There we are. Yields NaCl plus H2O plus CO2. All right, so these are going to react in a 1-to-1 mole ratio and produce a 1-to-1-to-1 mole ratio. So the deal is that 1 mole of sodium hydrogen carbonate does not equal 1 mole of carbon dioxide in mass, but we know that if we have 1 mole of sodium hydrogen carbonate react, we're going to produce 1 mole of carbon dioxide. All right, so let's go through a practice problem. So let's imagine that you reacted 5 grams of sodium hydrogen carbonate. And you wanted to know how many grams of NaCl you would end up with. Now, in the lab, it talks about how do we know we only have NaCl? CO2, nonpolar, therefore it's a gas, and it left the system. H2O, you evaporated away when you heated the substance, so all that should be left is solid NaCl. Now, how many moles of sodium hydrogen carbonate is 5 grams? That's what we have to figure out first. So, what we're going to be doing is saying if you have 5.00 grams of sodium hydrogen carbonate, the question is, how many moles is that? So I'm going to do this in one long equation. I'm going to say that if for 1 mole of NaHCO3, the mass of that is 84.01 grams. So I did my chemical inventory and I added everything together and figured out that this was the formula mass. Now, my grams of NH4CO3 will cancel with my grams of NaHCO3. Here, grams will cancel with grams, and I'll be left with my moles in my numerator. Now this helps me because now I can compare apples to oranges. I can compare, if I know how many moles of NH4CO3 I'm going to have, I can figure out how many moles of NaCl I'll have. Now here it's a 1-to-1 ratio. For every 1 mole of NaHCO3 that was used, I made 1 mole of NaCl. It's a 1-to-1 ratio. Now, if there were coefficients, that's where this would come into play, and you would put those coefficients in this fraction. Now that I have moles, canceling with moles, now I'm in my unit of moles of NaCl. I still need to find out how much this is going to weigh. So I'm going to put 1 mole of NaCl here in my denominator, and I'm going to figure out how much 1 mole of NaCl weighs. Well, Na weighs 22.99 grams per mole, and chlorine weighs 35.45 grams per mole. So altogether, they weigh 58.44 grams of NaCl per 1 mole of NaCl. Now, moles of NaCl cancels with moles of NaCl. So in my calculator, I'm going to multiply everything in the numerator and then divide by everything in the denominator. I'm going to show you a reduced version of this. So it's going to look like this. 5.00 times 1 times 1 times 58.44 divided by 84.01 divided by 1 divided by 1. Now, as you can imagine, all of these ones cancel each other out, or you can just ignore them when you plug into your calculator. So, cancel, 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 and I'm going to reduce this fraction down to 5.00 times 58.44 divided by 84.01. And that will tell me how many grams of sodium chloride I would expect to get. The main thing here is that whatever you use, you need to plug your amount in at the beginning of this problem. I'm using 5 grams as an example, but everyone will have a different mass.